We're doing day 2 of our function transformations. Recall that we were looking at y equals a f of quantity b times the quantity x minus c, close that, all plus d, and what the effect that a, b, c, and d had on the graph. Although I think we called these h and k, it doesn't really matter. Remember, a is being multiplied to f. F is our y value, so a is going to take our old y value and it's multiplying it by this number. D is being multiplied to this, or being added to this f, so it's whatever this old y value was, it's being added the amount of d, so it'll either move the graph up or down. When we're looking at x, we're always looking at the inverse, so the additive inverse. What we get when we do that, we get 0. And so what number would we plug in here to give us 0? It would be c. And so this would either be moving c units to the right, or if c was positive, if c was positive, or it would be c to the left if c was negative. And when we looked at multiplication, the key number was 1. What number would we plug in for x? Just thinking about the bx part to get 1, it'd be 1 over b. So that was our multiplication factor there. Now let's take a look at trying to get distinct examples where we're not applying too much at the same time. What is happening what does this do to the graph? Our key number is 1, so what do we plug in to get 1? 2. What this is, since this is multiplication for x, this is going to say multiply x by 2. What's happening to the y numbers? The y stays the same. So now when we look at our new x-intercept, our old ones were -1 and 4, so our new ones will be -2 and 8, because we'll just multiply them by 2. The y value there is still 0, since they are zeros, the x-intercepts. Over here, the max. What's going to happen? Only the x value is changing, so x is 2 times 2, or 4, so our max will be at 4, 30. The y value is not changing. The next one, 1/2 of f of x. What's being affected, x or y? That's the question you want to ask yourself every time. X is not being affected. We're multiplying 1/2 to the y value, the old f of x. So x stays the same. And then y, what we're going to do is multiply by 1/2. What you see is what you get for the y values. So our x values aren't changing. And over here, we're going to take just the y value and multiply it by 1/2. So 30 times 1/2 would be 15. So we get 2, 15. What's being affected, x or y? The x's, and we're subtracting a number, so we're looking at 0 is our number that our goal here. What would we plug in to get 0? It would be 1. This shifts the original f of x graph 1 unit right. So at x, and then add 1, and then y stays the same. So if we're adding 1 to -1, we'll get 0, and we're adding 1 to +4, we get 5. And then add 1 to the 2, and we get 3, and the y value stays the same, so that's still 30. The next one, it says 2f of x plus 1, so we have 2 things happening at the same time. And note, eventually we can build up so all 4 things are happening at the same time. It really doesn't matter as long as we're understanding that you apply each one in its proper order. And we're always going to deal with the multiplication transformation first. What's being happened to x? X is being shifted 1 unit right, so x subtract 1. And the y is going to be multiplied by 2. So if we subtract 1 from the x, and go back always to our original, -1 minus 1 would be -2, and then 4 minus 1 will be 3. Our max is at 230, so if we subtract 1 from the 2, we get 1. And we're multiplying the y values by 2, so that'll be 60. Now it says, find the equation of f of x, and it should say if f of x is cubic. Now, how can I do that? I'm going to need to know some information. I need to know a little bit more information in this, and I forgot to put that graph on there. So let me just sketch the graph right now. And I'm going to draw a graph like this. So this recalls what we did back in chapter 2 with writing equations for polynomials. Here would be 4. What do we know? This shows we have a single root at 4 and we have a double root at -1. So that'll say f of x equals x plus 1, remember it's x minus -1, quantity squared since it's a double root, times x minus 4. What am I missing right now? I'm missing my coefficient a. Remember, I need that because we don't know how stretched out or compact it is. Can I find a? What do I need in order to find a? I'm going to need a point. Do I have any other point on this graph? Yes, I have that max. That max was 2, 30, so I can plug in 30 equals a times 2 plus 1 squared times 2 minus 4. So this would be 3. Just be careful doing this. It's not that hard. You know how to do it, but people make simple mistakes going too fast. So we have 3 squared is 9 times -2 equals 30. So we have -18a equals 30. A equals 30 over -18. And 6 will go into this 5 times and that 3 times, so we'll have -5/3. Now, does it make sense that that is a negative answer? Yes, because it is going down to the right and up to the left, so that is a negative. We're not done until we write our equation. F of x equals -5/3 times the quantity of x plus 1 squared times x minus 4. Now let's apply these same ideas to another problem here. The first one, part A, that's just a pure review problem. Let's find the zeros of that. So let's factor out the x. It's a greatest common factor. We have x squared minus 3x plus 2. So we have x minus 1, x minus 2. Solve each one of those. We get 0, 1, and 2. What is the degree of this equation? It's a degree 3. And is it positive or negative? The leading coefficient's positive. So let's take a look here. We have 0, 1, 2. I'm just going to put some other numbers just in case. We have, let's see, it's positive, so it's going to go up from the last 0. It's a single root there. It's a linear factor, so it's going to go straight through it. If we were to zoom in, it kind of looks like a line, or it does look like a line. It's not. And then we come up here. And remember that the amount that this is going up is should be the same as this going down. They have the same amount for the x-axis there. That horizontal distance is 1. And I'm not doing it on graph paper, so it's not going to be perfect, but this will have to do for now. Now, it says on the same xy axis, so I'm going to need to deal with the same thing. I want to graph this. Now let's look closely at this new equation and the original one. The original one is x cubed minus 3x squared plus 2x, and we have 1/3 x cubed, just like this, minus 3, and then that amount squared plus 2 times that same x, 1/3 x there. So in other words, what we're looking at here is just f of 1/3 x. What does that do to the graph? Our key number, what's it affecting first, x or y? It says 1/3 times x. It's affecting the x value. What this is going to do is multiply x by 3. Because remember, 1's our key number. What number would I plug in to get 1? It'd be 3. And what happens to the y numbers? The y stays the same. So if my old zeros were 0, 1, and 2, my new zeros will be 0, 3, and 6. So I'm going to need to extend my graph out here. It would have been better had I drawn a better graph. I'm just eyeballing this one right now. So we have something that looks like this. We have zeros at 6, 3, and 0. And it's still a positive cubic, so it's going up. What's happening now? And we have single roots. The key thing here in terms of sketching this graph is y is going to stay the same. Well, if the y value is going down here for the original graph, the new one has to go down the same amount. Now, I'm not going to worry about the exact placement of where it hits that, but I do want you to have to hit that value and then come back up, and then similarly it'll be at this same value. Does it hit the low point here and the high point there at the midpoint between the zeros? Remember we had a problem that dealt with that? No, it does not. It's not a quadratic. Okay, cubics don't have that same where it hits in the middle. But right now we're just sketching this graph, that's okay. Will the max min y values change? No, the y values are the same.